In the previous video, we have looked at the basics of writing programs in assembly. This time, we will write a more advanced program and experiment with different types of addressing methods. We will create the code in both bitmachine and LMC syntax, as well as Python for a high-level language comparison. Our program will ask the user to pick a number between 1 and 5, then return one of 5 words, as well as the number of characters in that word. Let's start the code by asking the user to put in a number between 1 and 5. We can add a print instruction and point the operand to an address storing our message. The user now has to be able to provide the input. This input can then be used to select a specific memory address and print the word stored there. However, addresses 0 to 31 will be reserved for instructions, so the numbers 1 to 5 won't work for this purpose. We need to increase the number they choose to point to a valid memory address, such as 41 to 45 instead. So with the user's input still sitting in the accumulator, let's add 40 to it. We can now store this as user choice and declare the user choice variable at the bottom. It's time to add the 5 variables for our 5 rows. This time, instead of using labels, we will have to provide specific memory addresses to ensure we are definitely pointing at the right address. The user will select addresses from 41 to 45, so we add a word to each one of those addresses. When responding to the user, we should use full sentences, meaning we will have to concatenate some strings together. That is no problem. We declare the first half of the answer as a variable. We can then load that in, and to that, we add the value stored at the memory address selected by the user. The @ symbol means indirect addressing, and that the operand is not pointing at user choice. Instead, it's pointing at the address stored at user choice. So if the user chooses address 41, then the operand points to that address. If they choose 45, then the operand points to that address. We can now print the full answer. Let's assemble and see. Great! It's time to count the number of letters in the word selected by the user. For this, we will have to use index addressing to iterate through the word, letter by letter, counting the number of iterations. Bitmachine does not support both indirect and index addressing simultaneously, but we can work around that easily. Let's load in the word selected by the user and store it back into a known address, ensuring that an empty memory address is allocated for this purpose. Knowing the precise location of the word, we can now use index addressing to access individual characters of the string. Selected word 0 will give us the first character, and selected word 1 will give us the second character. What we need, however, is to be able to increment the index number in a loop to make sure we can iterate through the whole word. So let's use a variable and declare it with the value 0. This will now load in the first character of the word. In the previous video, we have looked at how index addressing works, and that Bitmachine uses a virtual null terminator, signified by a /0, to indicate the end of a string. So if we hit the end of the word, the instruction will return the value /0, and we can use this to determine when to end the loop. To check if the value returned is /0, we can subtract /0 from it and see if the result is 0. If it is, we hit the end of the word and we can print its length. If it's not the end yet, we have to increment the index variable by 1. We can do that by loading it into the CPU, adding 1 to it, and returning the result back to the same memory location. With the index number having been increased, we can jump back to the beginning of the loop and load in the next character. Once we reach the end, just like we did before, we can concatenate a message for the user. Load in the first half of the message, such as this word has, concatenate the index number to it, and finally the last bit of the message, such as characters. And we can print the result. We can now assemble the code and run it. The program asks us to pick a number, it then displays the associated word, and finally prints the number of characters in the word. If you would like to learn more about addressing methods, or how exactly the CPU executes programs, click on one of these videos. If you would like to try Bitmachine yourself, click on the link in the description.